All set, Courtney, or are we still waiting?
Nope, we're all set. You can start whenever you're ready.
All right, great. Welcome, everyone. If you just joined in here, I posted the Dropbox link to the work in the chat. We'll be working out of a notebook titled Code Challenge 3.1.22. We're going to finish up that notebook, then we'll move on to the next one. So I'll give everyone like 2 or 3 minutes to download and set up your environment and open up your Jupyter notebooks, and then we'll get started. All right, does anyone need another moment setting up their environment? All right, if not, we're gonna get started. So where we left off last time was with the SQL section. So we're gonna start with the first link. If you follow this link, the StrataScratch link, you'll come to this question. And for anyone who hasn't dealt with or used this website before, StrataScratch is a great resource for practicing SQL questions. They aggregate alleged questions that were asked at different like sort of FANG companies. And I'll just quickly go over the user interface in case you've never used this. So over here is a problem statement. Up here, you can choose what flavor of SQL you want to use, whether you want to use MySQL, Postgres, or you can use using NumPy and Pandas and Python. And over here, you just, this is where you write your query. And down here, you can run your code, and that will just make sure it compiles, and then you can submit your code if you feel like it's actually the correct solution and see whether or not you've got it correct. So we'll just read the problem statement together. So we have this workers with a high salary. What we want to do is we want to find the title of workers that earn the highest salary. We want to output the highest paid title or multiple titles that share the highest salary. So below here we have our, oh, sorry, I forgot to mention the tables that were given to solve this problem are listed below. There's a worker and a title table. And if you were so inclined to want to take a glimpse at these, there's a nice little preview button here. And it'll sort of make the table a little bit more easy to visualize. You can go down here and click on the title one. And it's the same case where we can just see a better visualization of the table. So are there any questions of the problem statement or how to use StrataScratch? All right, if not, let's take like 5 minutes to think about this problem and try to come up with a solution. So at around 10:13, we'll reconvene to discuss our ideas. I'll make some breakout rooms in case you guys want to discuss among yourselves. And if there are any questions, just message and or speak up. All right, welcome back, everyone. Does anyone have a solution, partial solution, or a thought process about how to approach this problem? Feel free to post anything you want in the chat. If you have any code you want to share or anything.
One sec. Sorry, I'm trying to.
Oh, you're good. You're good.
Yeah, I just need to fix. I was fixing my code because I misinterpreted the problem for a second.
Okay. Do you want us to wait, or you want us to?
You can go ahead. I actually solved a different problem that I was worried.
Oh, okay.
It was I got the highest salary for each individual role, not the highest salary overall.
Oh, I see. I see.
Yeah.
Okay.
I'm also
good.
So.
All right. Well, if no one has anything else they'd like to share, the only, I guess, trick about this problem is if we wanted the highest salary in the company, that would be a pretty straightforward query. But given like we want the highest salary across the highest salary across, it could be the case that multiple people from different departments have the same highest salary. So the highest salary for a company could be 300K, let's say, and it could be someone from accounting has that salary as well as someone from, I don't know, whatever, operations or whatever. So if no one has any code you want to share, we'll start off. So the first thing we want to do is I'll say, all right, I'll select, we'll select whatever from. So what's the first thing we want to do? First thing we notice is that we see that the information we want is in two separate tables. So the first thing I want to do is I want to join these two tables. So I'm going to say, worker, and then we're going to join it with the title table, and we're going to join on worker. The key to join them is the worker ID in the worker table and the worker ref ID in the title table. So we're going to say worker ID is equal to title dot worker ref ID. I spelled that correctly. Yes. Okay, so we've joined our tables, right? So now we have this joined table, and now what we want to do is we want to filter this out. We just want to find every person or every role that has the highest salary in the company. So how do we get the highest salary in the company? Well, we're going to filter with where. We want to say where we have some condition to satisfy. So we want to say where salary in, and then we're going to do another subquery, right? The subquery is what we want to find here is the actual max salary in the company or out of the workers table. So the way we do that, we just say select max salary from worker, right? So what we've done is we first join the table so we have all relevant information together. And then the next thing from this table, we want to filter out. We only want to consider the rows or the employees where their salary is equal to the max salary of the company. So that's what we're saying here. Where salary in this query right here is going to be a table with a single number in it. So we're just saying where, essentially what this line is saying is where the worker's salary is equal to the maximum salary in the company, right? And then up here is, well, what do we want to pull from this table? Really, we just want worker title, right? So I'm just gonna put that in right there. And hopefully as long as I have no typos, no syntax errors, if I run this code, all right, we see that allegedly from this company, the workers that had the highest salary in the company are, the departments that have the highest salary in the company are managers and assistant manager. So someone from the managing department, someone from the assistant managing department, or have the same salary. And if we run this code, let's click and solve, we see that we actually do get the correct answer. So are there any questions on this Strata Scratch question or on the logic of the question or just how to use the website? Does anyone have an alternative solution they'd like to share? All right. Well, if not, we will then move on to our next question. So we go back to the notebook. Oh, I've got too much stuff open. Go back to the notebook. We're going to work on Strata Scratch question 2. This second link here. Just click on that. I will delete my solution really quickly. All right. So for this one, question allegedly from Yelp, rated hard. So we're going to read this statement together. We'll see. We have top 5 states with 5-star businesses. So we want to find the top 5 states with the most 5-star businesses. We want to output the state name along with the number of 5-star businesses and order records by the number of 5-star, and order the output by the number of 5-star businesses in descending order. In cases where there are ties in the number of businesses, return all the unique states. If 2 states have the same result, sort them in alphabetical order. So we're given this big table. We've got Yelp businesses ID, and from that, we want to find all the 5-star restaurants and order them appropriately. Are there any questions on the problem statement? All right, if not, I think we'll just, this one's a little bit trickier, so we'll do 10 minutes. Oh, am I sharing the wrong screen?
Yeah.
Okay, well, it's fine. I think everyone's following well. Okay, if not, we will reconvene at 10:31 around. Give everyone 10 minutes. And again, if there are any questions or if you get stuck with anything or want like a hint, just feel free to speak up or message me in the chat.
Hey, Charles.
Yep.
I'm not sure if everyone is back, but I had a bit of or I guess I had a question
Sure.
on why am I, or something. Yeah, can I share my screen?
Yeah, sure.
So here we go. So this is the query. So what I noticed is, so my solution was identical, except for it included, I guess these are like Canadian. I think this is like maybe,
Quebec or something like that.
yeah, or something like that.
Who knows?
So, but other than that, it's identical. How would I, because there's no like country code.
Yeah,
How
can I
would-
see your code or your query?
yeah.
Okay, so the question says it wants the top 5 states with the 5 most
Oh,
5-star businesses, right?
I just didn't read the top. Okay, then I could just,
Yeah.
I guess, limit 5.
Yeah, that should be nice. Let's see. 10, 5, 4, 3, 3, 3. Can you scroll down to the solution output? 10, 5, 4, 3, 3. So it says you're missing Wisconsin. The official solution is you need Wisconsin. You don't have it. Oh, so the issue is, so if you have multiple states that have the same ranking, you want to include all of them, right?
Right.
So when you limit 5, you could be cutting off, like you're only looking at the top 5 of the table, but you're cutting off things that might have the same rank.
Gotcha.
So I think that makes sense. That might be the issue.
Okay.
Because so we select state count and then businesses from we're starting with 5, sure. Okay, so my solution has a few more steps. I'm not sure exactly where in your solution is. Oh, so you don't even rank the states actually. So I think your issue is that maybe you need to rank them. In my solution, I use the rank function, and then when you filter by rank being less than or equal to 5, that might get you the right solution.
Sorry, could you repeat that? You cut out for
So in my solution, I use the ranking function, the rank function.
Mm-hmm.
And then when every state gets its own rank, and then what I did was I just filtered out every state whose rank was greater than 5. So I was left with only the top 5.
Gotcha. Okay.
Right? Because if you limit 5, you're just returning 5. But if you have like a list of states,
Right.
who like that makes sense, right?
Yeah. That totally makes sense.
Okay. Does anyone have any code they want to share?
I shared in the chat.
Oh, sure. Let me just find that. Oh, yeah. I'm not sure dense rank would work for this problem, but we'll address that in a second. So this is Elliot's code. Elliot, do you want to walk through the code or anything? Oh, did you run it on your end? Oh, yeah. Okay. She's not responding, and there's an issue. So this looks like pretty similar to what I think it was David did. And the issue here is when you limit, the same issue is if you were just joining us, is there could be like states that have the same ranking. So when you limit, it could be possible that you're cutting off a few states that should be in the query when you just do a limit 6. You don't want to just limit your output. You really want to sort of filter out by a certain ranking. So if Ellie is not going to respond, I think I'll just walk through. Oh, hello?
Yeah.
Oh,
so yeah, this works on my end and I'm using my
MySQL. That's why, of course.
Yes. And
okay.
And you're right. So the first thing I did is just created the query without the limit. And then I looked at the output and then I noticed that we would have two states with the same number of 5 stars. So this is why I did limit 6, because I know we wanted to include the one that's like the 6.
Okay, so Oh, I see. So this works just by virtue of the data set. Let me share my screen, sorry. But it could very well be the case. Imagine you have, what if you have 30 states that have rank 3, right? So you, by virtue of the data set just not being big enough, you've been able to sort of bypass the problem. But what if you had like Illinois, Ohio, Wisconsin, whatever, New York, New Jersey, so on and so on, that all had 5-star count of 3, then you don't need to make limit 8 or limit 9 or limit K, right? So
Yeah.
it hasn't solved the problem for every possible data set. But you just happen to solve it for this data set because maybe the data set was too small. So this is a good start. I think there's just one more query we need to add to this, one more sub query we need to add to this to make it actually like correct for any case. So what we have here is we're going to select state count here. Let me just actually just for the sake of time, I'm just going to actually copy over my code and we'll walk through it instead of just typing it all out. So what I'm doing here, if I make this bigger. All right, so first thing I'm doing here, let me just comment all this out. The first step in my query was I just want to filter out, I only want to consider states, or sorry, rows where the rating was 5, right? So if I just run this code, then what I get is like, I just get all the rows where the rating for that restaurant or whatever in that state is 5. That was my first step. The next thing I did was now we want to consider this on a state basis, right? So the next thing to do is to group by each state and get the count for the count of 5-star restaurants in each state. So now if I run this, then what I get is similar to what we got for previous outputs is we get Arizona has 10 5-star restaurants, Wisconsin has 3, Nevada has 4, ON, whatever that is, has 5, right? Okay, so this is the part that we had missed in the previous solutions, is we can't just hard code a limit, because it could be the case, like I said before, that there's 4 states that have rank 3. So if we limit 5, we're going to cut off a bunch of data that we actually want. So what I do here is from the table that we have below, I do a further subquery, and I make this column called rank. And what I'm going to do is it's going to assign a ranking over the number. Over the number of 5-star restaurants in each state. So if we run this query, what we get now is see Arizona is ranked 1 as it should, since it has the most 5-star restaurants. Ontario or whatever this is ranked 2 because it has the most 5-star restaurants, or the second most 5-star restaurants, and so on and so on and so on. So now this is the trick. So now that we have a ranking, we don't need to worry about limiting our output, because now all we have to do is filter off of the rank, right? And if we filter off of the rank, then we know that no matter how many rank 1, rank 2, rank 3, rank whatever, if I just filter off that rank, it's not going to cut off any necessary data. So the next thing is we have this table. So the last thing, second to last thing, is now from this table, I just select from this table and I just filter out where the rank is less than or equal to 5. So when I run this code, what I get is the output in what happens to be the right, close to the right order, is I've got Arizona, Ontario, Nevada, Wisconsin, Illinois, Ohio. And we bypassed the problem before we had where we could have cut off data that we wanted by using the limit. So the last step is now we just order the whole thing by, first we want to order by the number of restaurants and then by the state. So that's how you do this with this last line. And when we run the code, we get everything in first numerical order, and then when there's a tie, it goes on to state. And this is the final output. And hopefully this should run. And this is correct. Yeah. So this is a decent problem in that, yeah, limit seems to work, but the problem is when you have duplicate ranked states. So that's where limit would not work, and you have to actually like rank them and then filter off of the rank of the state. Are there any questions or comments on the code or the logic of the problem? Or does anyone have an alternative solution?
No, that's very helpful. Thanks.
All right, great. Great. Yeah, it's sort of like the previous problem where like you can't just blatantly just like call something or filter out on some condition, because it could be that multiple things comply to that condition. So you have to be like a little tricky and like use its ranking function. All right, well, there's no questions. We're gonna go back to the notebook and we're gonna move on to our Python coding challenge for this notebook. So we just follow this leak code link. I will, once it loads, we'll delete my code. All right, so this question is called valid parentheses. We'll read the problem statement together as always. So given a string S containing the characters open parentheses, close parentheses, open squiggly, close squiggly, open bracket, close bracket, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets and open brackets must be closed in the correct order. Right, so we look at example 1. This is an example of valid parentheses because we see an open bracket preceded by a closed bracket, right? Down here, we also have a set of valid, a valid string because we have open whatever, parentheses, close parentheses, open bracket, close bracket, open squiggly, close squiggly. And down here, we have an example of a false, where we have an open parentheses being closed by a closed bracket. That's obviously invalid. So now, then back to the questions, we want to write a function that determines whether or not a string given these a string containing these characters constitutes a valid open closed squiggly. We want to determine if the string is valid. Okay, sorry about that. Are there any questions on the problem statement, or do you want to do a few more examples of what an open and closed or what a valid string would look like? All right. If not, I think is there someone in the chat? Sorry. Oh, it's just the link. All right. Well, there are no questions on the problem statement. Again, we'll break out into breakout rooms. And it's 10:44, so I think we'll actually reconvene at 11. This problem is, with leak code, the problem says it's easy, but it's only easy if you know the solution. So I think we'll give 15 minutes to consider to think about the solution, come up with a partial solution or a full solution, and then we'll reconvene at 12 to talk about what we've come up with. Again, I'll make the breakout rooms, and if there are any questions, feel free to message me and or speak up. Yeah. All right, welcome back, everyone. Does anyone have any thoughts, thought process, any algorithm or code they want to share to approach this problem? All right, if not, before we go through the code, I sort of want to talk about the algorithm of how to go about this problem. So up here, we have this is a valid string, right? We got everything has a corresponding closing bracket and everything's in the proper place. So I sort of want to think about how can we go about doing this computation with a computer. So the idea is we're gonna go through this string and we're gonna look at every character. And we're going to look at every character and we're gonna look at whether or not it's an opening or a closing bracket. And whether or not it's an opening bracket or a closing bracket is gonna sort of dictate what our next step is, right? So the open brackets is equal to this set of the open squiggly, the open bracket, and the open parentheses, right? And the closed is equal to, we got the closed squiggly, the closed bracket, and the closed parentheses, right? So here's what we're gonna do. We're gonna march through. And what I want to do, and I'm going to keep track of all the open parentheses, all the open characters I meet in a list. So we're going to initiate this list as some empty list to start off with. Right. And what I'm going to do is I'm going to track through every character, and whether or not it's open or closed, I'm going to do something different. Right. So this is what I'm going to do. I'm going to look at the first character. I'm going to say for every character in the string. So we'll start with the first character. If it's open, what I'm going to do is I'm going to add it onto my list. So that's what I'm going to do here. I'm going to add it onto my list. All right. Then I'm going to go to the next character. I'm going to say, if it's open, I'm going to do something. And if closed, I'm going to do something else. It's open. If it's open, I'm going to add it onto this list, right? So now our list is 2 elements long, each with opening, and they're all opening brackets. This list is always going to consist of opening brackets. All right. So now we get to the third element. And now we have a case where this is a closing bracket. So how do I know if a closing bracket is in a valid place? Well, I know that the last open, it's got to be right next to the last opening bracket, right? So I'm going to look at this element, and what I'm going to do is I'm going to look at the last opening bracket in my list. That's this thing. I'm going to look at this guy. I'm going to remove from the list this closed bracket. I'm going to remove from the list. And now I know this open bracket is this closed bracket is in the proper spot, because the last open bracket that I saw, right, this list was originally this. I know that this is valid because the last opening bracket I saw closes this closing bracket, right? So I know that at this point, I still have a valid string, right? So what I've done is I've removed the last closed opening bracket from the string. I've compared it to the closing bracket to make sure that they're matching pairs. And they are, so I'm going to continue on with my algorithm, right? So now I'm going to move on to this opening bracket. Since it's an opening bracket, what I'm going to do is I'm going to add it onto my list. All right. And then I go to the next character, which is a closing bracket. So what I do is I pop the last element from my list, this guy. I look at it. I say, does this opening bracket match the closing bracket I'm on? They do. These are matches. So I continue on, right? So now my list is 1 element long, and it's just the original opening bracket. I opening squiggly I started with. So now we march over to here, right? And I'm going to do the same thing. It's a closing bracket. So what I do is I pop the element from my list, this guy, and I look to see whether they're a matching pair. They are. Ooh, they are. So I pop it. I compare. You know, these guys are equal. So I go on. I've got to the end of my string and I realized I've had no issues. So since I've got to the end of my string, I'm going to return true. I've realized I've gone through this whole algorithm. I've never got to a case where this wasn't a valid string. So now I want to run through a case where this would not be a valid string. So if I start out by something like this. This isn't valid, right? There's no opening bracket corresponding to this character. So we run through the algorithm again. What I get is my L is going to look like this, I go to the next guy, it's an opening, so I add it onto my list. All right, now I get to this guy. So when I hit a closing bracket, what I do is I pop the last element, this guy, and I compare. Are these guys corresponding matches? They're not. So now I know that this can't be a valid parentheses because I know that this guy doesn't close. Its closing partner is not of the same type, right? So I know that this can't possibly be a valid string, and I automatically bomb out of the function and I just return a false. All right, I just want to go through one more example to iterate, just one little like sort of edge case of this algorithm. If I have a string like this isn't a valid string because this first opening bracket does not have a corresponding closing bracket. So we run through the algorithm again. What happens is we have our empty list. We look at the first character. It's an opening. It's of type open, I'll say. So I add it to my list. All right, the next guy is of type open. So I just add it to my list. This third guy's type closed. So what I do is I pop the last opening guy I saw, which was this. And I compare it. Okay, these match. They are corresponding opening and closing. And we're done. We've gotten through everything. I haven't bombed on any condition. And we're done. So my algorithm will probably return true. But the reason it shouldn't return true is the last thing I need to check for is I need to make sure that I get through the whole string and that by the time I get to the end of the string, my list is empty. Since I still have an element in this list, what that means is that I've observed an opening bracket that has I've yet to observe a closing bracket. And since we've gone through the whole string, there is no closing bracket to this opening bracket. So I know it's not valid. So that's the last thing we need to check with our algorithm is we need to make sure that once we get through the whole string, we haven't terminated, bombed on any cases, we need to make sure the list is actually empty to make sure that we are corresponding for cases like this, where we have this set of valid ones, but we've never seen the closing bracket for this first character. So does that algorithm make sense or sort of start to make sense to everyone? All right, well, we're going to code it up and hopefully that'll make it even more clear. So I'm going to share. So do the same thing as before. Same thing as the pseudocode. What I'm going to do is I'm going to start with a list. I'm going to say just some list is equal to some empty list. And I'm going to make a dictionary. And what the dictionary is going to hold is the opening brackets are going to be the keys and the corresponding closing brackets are going to be the values. So I'm going to say is, and this is just to make the code cleaner. You don't necessarily need to do it this way. It's not pertinent to the function of the algorithm, but it just makes a much cleaner code, I think. So I'm going to say this opening bracket, its corresponding closing bracket is this guy. This opening bracket, its corresponding closing bracket is this guy. This opening bracket's corresponding closing bracket is this guy. Make sure I did that right. Yeah, that looks about right. All right. So now we're gonna do what we said before. The next step is now we want to iterate through every character in our string and determine whether or not it's in a valid position or whether or not it's a part of a valid valid string. So I'm gonna do it, I'm gonna say for C in S. We're gonna iterate for every character in S. I want to say if, what do we check for first? First, we want to see whether it was open or closed. So does anyone know how I can do that with this code I've written so far? Here's what I'm going to say. I'm going to say if C in D. What that means, if you say for C and D, what this is going to do is going to check all the keys. When you say this, if I said D dot values, it will check all the values. But when you just say D, by default, Python is just going to look at the keys of the dictionary, right? So this is equivalent to saying, you know, if C is an open bracket. That's what that's equivalent to saying. So we're going to say if C is an open bracket, well, what do we do if we see an open bracket? We just add it to the list, right? I'm going to say L dot append the bracket, right? Okay. So this was the case if C was an open bracket. But now we need to consider the other case where we have, what if we come across a closing bracket? So I'm going to say else. I'm going to say, there's one more case I want to consider. I want to say if not L, return false. What this is saying is if our list is empty and we still have characters to consider, it can't possibly be a valid string, right? It's the exact opposite of this case. If we have something like this, then when we run our algorithm, we have L is equal to, we start off with this, we get to a closing bracket, we pop L, we pop the first element, the last element of L, so now L is empty. And we compare these two and they're equal, right? Now we go into this character. It's a closing bracket, but we have nothing in our list to compare to, so we know it can't be valid. So what we're gonna say is if L is empty, right? If not L, we're gonna return false. We know it can't possibly be true. Otherwise, what we're gonna do is I'm gonna say closing parenthesis is just going to be equal to D of C. Right? We want to get the corresponding closing parenthesis to this character. And now when we say is, wait, no. If not L, return false. Here's what we do. I'm going to say parentheses is equal to L dot pop. We want to look at the last guy, right? So now what I'm going to say is if C is not equal to D of P, I'm going to return false, right? So we said we're going through our string. We say if C is a D, otherwise if C is an open bracket, we're going to append it to our list. Else, first we check to make sure L is not empty. And if it is, we know we don't have a valid string. So we return false. Otherwise, we can say parenthesis is going to be equal to the last C in parentheses. We pop from the end of the list. And now what I want to say is if C is not equal to the corresponding closing parenthesis that we get here, D of P, then return false, right? So if C is equal to this, and D of P is not equal to the closing parentheses, then we know we have an invalid string, and we just return false because at that point we know that we have an invalid string. All right, so this is our main for loop. We iterate through the whole thing, and if we have an empty list, we eventually bomb out, return false. If we find some mismatched parentheses, we return false. All right, but if we get through the whole list, like I said before, we have one more case to consider. I can go through the whole iteration and not bomb out. The last thing I want to check for is I want to say if not L, meaning if L is empty, then we want to return true, right? Else, we still have something in our list, we want to return false. So once again, this is our whole algorithm. Just to reiterate, we start with an empty list, and we just have this dictionary of corresponding values of the opening and closing brackets. And we look through every element of our string. We say if the element is an open parentheses, we add it to our list. Else, we first check to make sure the list is empty. And if it is empty, we return false because we know we can't have a valid string. Otherwise, I'm going to look at the last seen open parentheses, right? And I want to say if this closing parentheses C that I see now is not equal to the last seen open parenthesis, they aren't corresponding parentheses or brackets, then we want to return false. We know we have a mismatched bracket. It can't possibly be a valid string. We bomb out and return false. If we get through this whole loop without bombing out, then the last thing we want to check is that make sure L is empty. If L is empty, we return true, else return false. And hopefully if I've done everything correctly, when we run the code, we've passed the test case. If I submit, it runs. Are there any questions on the logic or anything for this problem? Okay, if there's no questions, I will leave the code. I'll just copy and paste the code into the chat in case anyone wants to sort of go over a little more. And once again, what LeetCode calls easy is not necessarily actually easy. Let me just post in the chat. Okay, so right now it is 11:16. I think we'll take a break till 11:20. We'll take a 5-minute break, and then we'll resume and we'll start working from this week's notebook titled Coding Challenge 3/11/22. So see you guys in 5 minutes. All right, welcome back, everyone. I just noticed a chat from Yuta's son. She has a solution to is valid that I feel like I've seen this before. The issue with it is, actually, let me just pull up the code and put it into a Jupyter notebook so we can all take a look at it. So what the person here is doing is it's a little trick. It's clever, I guess, but the issue with it is the runtime. So this solution, what it's doing is it looks at a string like this. I'm on mute. Nah, all right. It looks like at a string like this. And what it does is it looks for 3 different strings. It looks for something like this, and something like this, right? So it says while any of these strings exist in this string, what it does is it removes them. So if we look at this string, I'm going to say, well, this string here exists in the string. So what I'm going to do is I'm going to remove it. So when I remove it, I get a resultant string like this. What I get is this. All right. So now again, I check, do any of these strings exist inside this bigger string? It does. Oh, sorry. It does, right? This inside parentheses. So what I do is I remove it. Gone. I get this resultant string. Again, I check, does any of these 3 strings exist within the new string? It is. Gone, I remove it. All right, so now our string is empty. So we know it was a valid string because we were able to remove every single set of parentheses. So we do the same, if we run through another example where it would output false, what happens is we have this, we have this, we have this. This is obviously not a valid string, but we're going to run through the same logic. We're going to look through these 3 different substrings and see if they exist in our string. Well, this does exist, right? So we remove it and we're left with this. All right. But now none of these 3 substrings exist inside this string. So we break out of our loop and we check to see the length of the string, right? If the length is 0, we know we were able to remove everything from the string without an issue and it was a valid string. But if the length is more than 0, then we know that we have an invalid string. So the length of this is obviously 2. So we know that is not valid. The issue with this is every time you do this line here, this is creating a new string, right? Strings are immutable in Python. And every time you do this s.replace, you are creating a new string, which is if you have a string of n characters, it takes O of n time to do it, right? And let's say you have k matching parentheses in your loop. Oh, at most you'll have n over 2 matching parentheses, right? If in a valid string given n characters, you'll have n over 2 matching pairs, right? So what your runtime is, you have to go through the while loop n over 2 times, and to recreate the string, that's O of n, right? So what we get is something that's n squared over 2 runtime. And when we take the big O notation, we drop any multiplicative factors. So we get this is O of n squared. So that's the downfall to this solution. The solution is clever. I don't know, depends if you ask if it's clever or not. But the downfall is that it's O of n squared, where our solution before, we were just iterating through the string once. We weren't creating any new characters or anything. We were just iterating through the string and checking certain conditions. So our solution is O of n. The downfall to our solution is that our solution's memory complexity is also O of n, because we had to keep a list of all the opening characters. And like we said, at most n over 2 opening characters. So that's memory complexity of O of n squared, where this solution uses no extra memory. So its memory complexity is O of 1, but you have this time complexity of O of n squared, which is abhorrent. Like this is not a scalable solution. And you can play with this yourself. If you take my code and then this code and you time them on massive test cases, you'll see that my code will run linear with the size, and this code will eventually just not run at all. Any questions on that, on the time complexity or memory complexity of either functions, either solutions?
Yeah, that makes sense. Thank you.
No problem. All right. So if we go over to, so this is the notebook for, let me share my screen. Here we are. All right, so we got this cute little probability question I saw the other day. I thought it was pretty decent. We'll read the problem statement together. So given a standard deck of cards, of 52 cards, what is the probability that when I randomly pick 2 cards, the first card has a lower value than the second? And what's gonna happen is we pick the first card, we don't replace it, then we pick the second card and we then do the comparison. right? And in case there's any question on the ordering, we have obviously 2 is less than 3 is less than 4 is less than whatever, so on. And when we get to Jack is less than 10, sorry, 10 is less than Jack, and Jack is less than Queen is less than King is less than Ace. So that's the ordering of the deck. And we want to find the probability that given we pick 2 cards, what's the probability that one card 1 is less than the other, is it less than card 2? I will say about this question, I was attempting to solve it brute force, and it became very, very messy. And one of my friends said, if you sort of restate the problem, if you try to look at it in a different light, the problem becomes way less computationally expensive. So that's just a little hint. We'll take about 10 minutes to think this one over. No, we'll take 5 minutes to think this one over. I don't want to spend too much time on it, and then we'll come back and we'll discuss our solutions or our thought processes. So at 11:32, we'll reconvene. And if there are any questions, once again, feel free to post in the chat or speak up. All right, welcome back, everyone. Does anyone have thought process or solution they'd like to share? All right, if not, I'll share my thought process. So initially I was doing the problem, had this long, complicated expression to try to solve this. And my friend said there's another way to think about it. If instead of considering where card 1 is less than card 2, let's first consider the probability that card 1 does not equal to card 2, And if you consider that, it makes the solution way less complicated to think about. So we pick card 1. Doesn't really matter whatever card 1 is. We pick it. All we want is card 2 to not be equal to it. So what's the probability of that? So we pick card 1. We don't replace it. So now we have 51 cards in our deck, right? And we just don't want to pick the same card. We don't want to pick a card that has the same value. So out of our 51 options, how many options do we have to pick a card that's not the same value of card 1?
48.
Exactly, yeah. So we get the probability that card 1 is not equal to card 2 is just the probability of this. Is just equal to, well, we have 48 other cards to choose from out of the 51 remaining cards, just the card 1 is not equal to card 2. And does anyone know the last sort of logical step, not logical, the last step to sort of get the actual complete solution? We've instead of considering card 1 being less than card 2, we considered card 1 not equal to card 2. There's one last sort of step. So something to notice about the problem is that there are just as many cases of card 1 being less than card 2 as there are cases of card 2 being less than card 1, right? It's a symmetric problem. The amount of ways you can pick a card 1, such as it's less than card 2, is equal to this. It's the same amount of ways that you can pick card 2 being greater than card 1. The problem is symmetric, but we only want to consider the card 1 being less than card 2. So we only want to consider half of these possible draws, right? So the last step is we just take the probability of card 1 not being equal to card 2 and just divide the whole thing by 2. So our final solution is 48 over 102, and whatever that reduces to, that's the final answer. Any questions in the logic for that, or why the problem is symmetric?
Can you go over that one more time?
Yeah, sure. So we reframe the problem from card 1 being less than card 2 to first considering card 1 not equal to card 2. We get 48 over 51. That's fine, right?
Yeah, that part I get.
Okay. So now if we want to consider card 1 less than card 2, what we realize is that the number of ways for us to pick card 1 being less than card 2 is equal to the number of ways of card 2 being less than card 1.
Kind of like a coin toss then?
Yeah, like the problem is like it's symmetric, right?
Okay.
It's because the labels card 1 and card 2 are sort of ambiguous. So if I want card 1 to be less than card 2, the number of ways for that to happen is equal to card 2 being less than card 1. Does that make sense? That's like it's like a little iffy, and I'm still like almost like not sure of it, but that actually is the case.
Okay.
And so since we only want to consider the ones where card 1 is less than card 2, we only want to consider half of all those possible outcomes, right?
Oh,
And since
okay.
the problem is symmetric, we just divide out the outcomes we don't want, which is just the other half, right?
Got it. So basically
that's why-
multiplying it by half.
Yeah, exactly.
Okay,
Yeah, multiply by
okay.
1/2 or divide.
Yeah, okay. All right.
All right. Any other questions? Yeah, multiplying by 1/2 is probably a better way of thinking about it, because we have the probability of card 1 not being equal to card 2 times the probability of card 1 being less than card 2. This is a better way to think about it, or to look at it. All right. If there are no other questions on that problem, we're going to move on to the SQL question for this one. And for this one, we don't have an actual environment to test our code in. This was just actually a problem that my friend recently got on an interview, and I thought it was pretty decent. So we are going to quickly go over the problem statement, and I'll draw the table. So this is from a company called Citizen. They have an app where it's like sort of like You can video record or report, crime in the area you're located at. So the problem is as follows. You have two tables. One table has user ID and the time they opened the app. So time open. The other table has user ID again and time they closed the app. All right, wait. Okay, one user ID the time open, and the other table has user ID time closed the app. What we want to do is we want to write a query to calculate the average time a user spends on the app. So imagine we have whatever user ID A, B, C opens at 12 o'clock, 1 o'clock, 2 o'clock, and we have A, B, C closes at 12:30, B closes at 1:30, and C closes at 2:30. We want to write a query that calculates the average time each user uses on the app. So there's gonna be some joining involved. There's gonna be some interesting filtering that you need to do to get valid open close times. So are there any questions on the problem statement? All right, if not, we'll take, someone in chat. Oh yeah, 48 out of 51, sorry about that. Okay, so if not, we're gonna take 10 minutes to think about this problem, and then we'll reconvene and we'll discuss our solution. So at 11:48, we'll come back to discuss our solutions, and I'll make the breakout rooms again. Welcome back, everyone. I think this is the time I said we reconvene. Does anyone have any solutions or thought process to this problem? Okay, if not, we will recreate it. So everyone can see this notebook I'm typing in, right? Ooh. Here, this is, everyone can see this? Yes.
Yes.
Okay, all right. Oh, okay, yeah. So we have all our open app times and our closed app times are in two separate tables. So of course, what we want to do first is join the two tables. So we're going to say select, we'll select, we'll call open table dot user ID open time, close time from we want to say open table join close table on open table dot user ID is equal to close table dot user ID. So this will join the tables. But does anyone see exactly what the issue with just doing this is? Or what the next step is? So imagine I have in user ID, A opens the app at 12 o'clock. And let's say A closes the app at 12:30. Okay, now let's say A opens the app at 1 o'clock, same user, and then A closes the app at 1:30. What our table is going to look like when we join them, our table, the resulting table is going to look like this. It's going to be user A, 12 o'clock, 12:30, you know, for open, close, and user. And we're also going to have a row for A, 12 o'clock, 1:30. And we're going to have a row for A. It's going to be 1 o'clock, 12:30. And we're going to have another row for A, where we're going to have 1 o'clock, 1:30. So just from this little example here, does anyone see what we need to do for the next step? There are some problematic rows, right? We know in this query, the only two times the user A open and close the app was from 12 to 12:30 and 1 to 1:30. But when we join our tables on user ID, we get four possible open and close rows, right? But we only know 2 of them are valid. So the first thing we want to check is, well, first of all, obviously the open time has to be before the close time, right? So we can automatically get rid of this row here, right? So we're gonna filter out all rows where the open time is before the close time. So we want to select, you know, all this. So this is our join table. So what we're going to do from here is going to say select all from, we'll just tab this as whatever, T1, give it an alias. Even though we're not going to run this code, it's still nice to be syntactically rigorous. Where we're going to say open time is less than, let's say less than or equal to close time. Right, we only want to consider those times because when we joined our table, we've created some false data, right? We had in our table only 2 instances of the app being used, but when we join, we get 4 instances. So we need to filter out all the not real instances of the app being used. So of course, the open time being less than the close time is a way to filter out some. But now we have another issue. If we look, we know they only opened the app at 12 o'clock and 12:30 and 1 o'clock and 1:30, but we have this row that says it opened it up at 12 o'clock and closed it at 1:30. That data is not in our table, right? So what filtering technique can we use, or what condition can we impose on the query so that we filter out this Fugazi row here? This 12 to 1:30 never really happened, right? So we need to find a condition or do something to sort of eliminate these rows. All right, so what we're going to do is we're going to group by user ID and open time. So we're going to group by user ID and open time. And what we're going to do to find the valid close time is, what are we going to do? What aggregating function are we going to oppose on the close column to get the valid close time for an instance?
Minimum.
Exactly, right? Because 12 to 1:30, if the user A opens it at 12, then the next, then it closes, the time they close the app has got to be the minimum close time in that group, right? Because you can't open the app and then open the app again. You've got to open the app and then close out at the next time. And then you can open up again at some time after that. So we want to take the minimum of the close time when we group by user ID and the open time. So that's what we're going to do next. So from this query, I'm going to select, let's select all, comma, and we said we want to do the max. Well, let's select user ID, open time, and then we're going to select the minimum of the close time from this thing. I will again tab it for slight better readability. And again, we want to alias this. And what do we say? We want to group by user ID and open time. Oh. Right. So now when we do that, if we look at our resulting table, so we already filtered out obviously the row where the open time is after the close time. This can't physically happen, of course. So now if we group by open times, what happens is these guys get grouped together, right? But then we only take the minimum close time, right? So we're going to take this guy, and that eliminates this guy. And when we group by this guy, there's only one guy in it. So now we have 1 o'clock to 1:30. So we've successfully eliminated these two non-existent uses of the app. Any questions so far? Okay, so that was really the crux of the problem. Really, the crux of the problem was to figure out exactly how to eliminate all non-existent uses of the app when you join the table. From here, it's just we want to find the average time. So from here, does anyone know what we do from here? We're just going to select all from, select all, and we're going to say average of open time minus, sorry, close time minus open time. As average time from this massive table, and we're going to group by user ID. Any questions? All right, and this is a solution, right? We join the table, we filter out the problematic rows that were created from joining. And then once we filter out the problematic rows, we have all valid instances of the app being opened and closed. And then from there, it's just as simple as grouping by every user ID, taking the time they spend on that app, and just averaging all those times. And that's the answer. Are there any questions, any concerns, any comments?
So in a real coding challenge problem, would it be better we use a temporary table, or I forgot the name of the,
Oh, a
so
CTE.
instead of nested query,
So
would it be better?
that depends. It could be. It's definitely better for readability to use a CTE and naming it. Instead of using these, ridiculously bad names T1, T2 for a coding challenge. If you're using PostgreSQL, then you can use CTEs, which are auxiliary table that you can save as a variable name. But in MySQL, if your whatever your environment only supports MySQL for whatever reason, the employer only is using MySQL. CTEs don't exist in MySQL. They exist in PostgreSQL, but not MySQL. So it's good to ask them. I mean, you potentially could ask, hey, like, what environment am I in? Can I use CTEs? Because you're right, CTEs will always make the code more readable and more manageable, but they need to be possible to use them, right? So you'd have to ask about exactly what environment am I in?
Yeah, got it. Thank you.
All right. Oh, was someone about to say something, or was that in the background of someone's? All right. Well, we only have 5 minutes left, so I think in this time I'm just going to introduce the first Python coding challenge, and then next time we'll review the questions. So feel free in your own time or whatever to take a crack at these guys. So we follow the first link for the Python challenges. We get to this problem. That loads. I will delete my code. So we'll read the problem statement together as always. So given a binary array nums, return the maximum number of consecutive ones in the array. So we got some array like 1, 1, 0, 1, 1, 1. We want to write some code that will go through this array and sort of calculate that 3 was the maximum length of the consecutive ones. And in the example below, we see the same thing is we have this array and we see that we have 2 consecutive ones, so the output is 2. And same thing over here, we have 3 consecutive ones, so the output is 3. So this class of problem, it's called, I guess you can call it like double pointer problems. It's where you initiate 2 variables that sort of act as pointers, and they iterate across the array, and you sort of update their position based off some condition you meet. So are there any questions on the problem statement? All right. Well, I urge you guys, everyone, to try it, give it a shot now. I'm not going to go over the solution now. We'll go over it next time just because I don't want to rush through it. But if you find yourself at a bit of a loss, don't know exactly how to approach the problem, if you Google like double pointer method or 2-pointer method for like algorithm problems, you'll find a bunch of resources, and hopefully that will inspire you to that will inspire a solution. Oh. Yeah, we'll be back next Tuesday. So are there any questions from anyone on anything we covered at all this whole session? Okay, if not, then that's all I have on my end. Again, like I said, feel free to look at the other lead code problem too. And if you get stuck on this one, again, if you Google some resources on double pointer methods and algorithm problems, you'll find a bunch of resources that will hopefully stimulate some solution. If no one has any questions or anything, then I think that's it for me. Thank you everyone for joining, and see you next time.
Thank
Peace.
you.
Thank you.
No problem. Take care. Bye-bye.
Have a good one.
Take care. Have a good one.